Which of the following is the solution to the differential equation given with the initial condition that when x is 0, your output is negative ln 4? Remember, when you're solving a differential equation, you have to separate the variables. So you've got to have all your y's on one side and all your x's on the other side. The problem is that our x and y's, our x and our y, are both up here in the exponent position. So we're going to have to do some algebra before we can separate these. And the way you separate the x and the y here is to remember the rules for exponents kind of in reverse. We would rewrite this e to the y plus x is e to the y times e to the x, because if you have the same bases, then you can add the exponents. So since our exponents are added, we can write this as the product with the same base raised to each of those powers right there. So hopefully that makes some sense. And so that's what dy dx is equal to. That's just another way to write that. Now, since our x's and y's are separated, we can actually separate them from both sides of the equal sign. Our dx is going to come to this side over here, and we're going to have to divide by e to the y to get it over there with the dy. So we end up with dy divided by e to the y is equal to e to the x times dx. And when we do that, we can integrate both sides. Be careful about where you put your, when you divide, make sure you put that on the bottom. Don't let it end up on the top. Your dx is always going to be on the top. You would never move your dy over here and your dx or the e to the x over there. You can't have a 1 over dx right there. It doesn't make any sense. Okay, so now we just have to integrate both sides. And if we integrate 1 over e to the y, another way to write that is e to the negative y dy. So then we could use a u substitution on this and call u is negative y, which would make our differential u be negative 1 differential y. So we're missing a negative here. We need a negative with our dy, so we're going to put a negative there, but it's multiplied, not subtracted. And to compensate for putting that negative, we put a negative out front. So that gives us negative, and then negative dy is du, and we have e to the u right here. So that gives us negative, and the antiderivative of e to the u is still e to the u, and our u is negative y. And remember, our plus c we're going to accumulate on one side, on the right side of the integral. Technically we'd have an arbitrary constant right here, but since the constants are arbitrary on both sides, we're just going to add them on the right side. So that's the antiderivative there. If we take the antiderivative of e to the x, then it's going to be e to the x, and then here's our plus c, which again compensates for both sides. Now we have an initial condition that y at 0 is equal to negative ln 4. So we're going to substitute in right here and solve for this arbitrary constant c. So that means if my x value is 0, then my y value is negative ln 4. So I get minus e to the opposite of y, and y is negative. So if I have opposite and negative, that becomes positive ln 4. And then e and ln next to each other are going to cancel each other out, and that 4 is going to drop down, and this is going to be negative 4. And e to the 0 is going to be 1 plus c, so subtract the 1 to this side, and c is equal to negative 5. So now we want to take this c value back up here and substitute it in for c, and then solve for y. Just like that, we'll have our answer. So I have negative e to the negative y is equal to e to the x minus 5. And now comes the joy of separating or solving for y. So what I want to do is divide everything by this negative, because if I natural log both sides at this point, that negative is going to be in the way. So I'm going to divide both sides by negative, which makes that positive, makes this negative, makes that positive. Just changes all the signs all the way across. And now I can take the natural log of both sides. and that negative stays in front of that e to the x plus 5. And since that negative is between that natural log and that e, they did not cancel out. So here ln and e cancel, and I have negative y is equal to natural log. I'm going to write this positive 5 first, minus e to the x. And then I want to divide both sides by negative 1, which puts a negative in front of that natural log. And let's hope that that answer is there. So y is equal to negative natural log 5 minus e to the x. So there it is right there. Answer choice C.